Alright guys, we're going to be looking at another special quadrilateral today. The one we're going to be looking at is a rhombus. So here I have a picture of a rhombus, rhombus ABCD, and then the definition is written up here. Now, a rhombus is a quadrilateral, but in fact we can be a little bit more specific. In fact, it's a parallelogram. With four congruent sides. You can see that the congruent sides are marked again with these tick marks in each side. So if this side was 7 1/4, all the other sides would be 7 1/4. So again, this is just the definition. We're looking at strictly the definition of a rhombus. What we're going to be looking at next are the special properties of a rhombus. Now, the special properties of a rhombus are a little bit more in-depth and a little bit more angle-based than what we looked at with the rectangle in the last video. So let's see if we can write them out. So property number one for a rhombus is the following. All rhombuses, or rhombi, I think it's are parallelograms. And I know we wrote that in the definition, but I think it's worth writing it down as its own separate property because this also has some really important implications as well. Because all rhombuses are parallelograms, that means that rhombuses have all the properties of a parallelogram. So within property one, we actually can have the four properties of the parallelogram, being opposite sides, are congruent, which should make sense because in a rhombus all the sides are congruent. We have opposite angles congruent. We have consecutive angles are supplementary. And lastly, we have the diagonals bisect each other. And again, these were all properties of a parallelogram, but since the rhombuses are parallelograms, they also share this property. Now, if you want to see visuals of these, if you want to see visuals of all four of these, I'm not going to draw out the picture. You can see my video on properties of parallelograms. I have a whole video that describes and gives diagrams of what these four properties are trying to say. And you'll see that these are really helpful in solving some of the angle measures and side lengths inside of a rhombus as well. There we go. All right. So now let's talk about the properties that are specific to just rhombi. These will not work for a parallelogram. These will only work for rhombuses. I'll make sure we make a special note of that. This is true only for rhombi. Now, the first one we're going to look at, beyond just the previous, was the diagonals of a rhombus are perpendicular to one another. So now we have something special about the diagonals. Let me switch this to a little lighter color. The diagonals. Switch that color. the diagonals. It's an important word. The diagonals are perpendicular to one another. And I'll draw a little sketch of one for you guys so you can see what that means. So I'll do my best to do a nice little sketch of a rhombus for us. So here's a rhombus, not my best work. Again, we'll say this is a rhombus. Rhombus. When it says the diagonals are perpendicular to one another, remember here's also notation for perpendicular, a little upside down T. If we draw our diagonals in, again, that's just connecting two non-adjacent vertices. All of these angles will be 90 degrees. It splits these up equally. 90, 90, 90, 90. And what's nice about this is that means inside of these rhombuses there are 4 right triangles. And we know that right triangles have some very special properties, so especially when it comes to solving side lengths or finding lengths. So we'll keep that in mind. Good so far? This is very, very helpful for us. Again, the diagonals, just the diagonals, not the size, not the angles, interior angles, just the intersection will have all 90-degree angles. They're perpendicular to one another. Good so far? Excellent. The next one we're going to look at. All right, so the next property of a parallelogram also deals with its diagonals. The next property, again, this is only for rhombuses. Only for rhombi. It says, in a rhombus, the diagonals bisect each interior angle. So each one of these diagonals splits. For example, angle B would be split in half. These two would be the same. 1 and 2 would equal one another. 5 and 6 would equal one another. And in fact, since it has the properties of a parallelogram saying that angle B and angle D are the same, each one of these angles, and in turn, will be congruent to one another. Angle 1 will be congruent to angle 2. Angle 5 will be congruent to angle 6. And it's pretty easy to see we'll have the same properties with 3, 4, 8, and 7. That's why I kind of color-coded them for you. Angle 8, again, this is being split in half. These two are going to be the same. Angle 8 is going to be the same thing as angle 7. Angle 3 is going to be congruent to angle 4. These lines, these diagonal lines inside of our rhombus are going to split each one of these angles into 2 exactly equal pieces. In fact, I'll even do one as a kind of as a diagram for you guys, so that way we can just kind of see what the numbers look like. All right, so we have all these angles marked up. So let's check one out. So if I have, I'll do a quick little application here, even though there'll be another video that kind of goes into this a little bit more in depth. Move this stuff out of the way. Put a little bit more space. All right, so if we're looking at this problem here, let's put some numbers into it so we can kind of see, make it a little bit less abstract. If I know that angle 8, say angle 8 is 42 degrees. If you know one of these angles, in fact, you can fill in all of the angles in it. We know that these two angles have to be the same, Right? That's the property that we were just talking about. We said that angle 7 and angle 8 are congruent because the diagonal splits them in half. So this is also going to be 42 degrees. So angle A, in turn, would equal 84 degrees. This whole angle is 84. Now we can use this angle measure to help us find the rest of these pieces. Because we know angle A is 84, we also know that angle C also equals 84, right? Opposite angles have to be the same. One of the properties of a parallelogram from about 2 slides ago. So if we know this angle is 84, also angle 3 and angle 4 are going to be 42 degrees. Because it keeps splitting the angles in half. These diagonals split both of these in half. So you can see it's very helpful to see that, oh, on each side of the diagonal on both of these angles are going to be exactly the same. Now let's see if we can use another property of parallelograms. Does anyone think they can tell me what angle D equals? All of angle D? Anyone think they can tell me what angle D is equal to? Yes, angle A and angle D are going to be supplementary to one another because they're consecutive. So if I know the two of these angles add up to 180, it's pretty easy for me to solve the other one. So this one is 84. We do not know the measure of angle D. I'm going to call that angle D, letter D. Subtract 84, and yes, what is it going to be? It is 96. So angle D equals 96 degrees, which again is very helpful to us. What other angle is going to be equal to 96 because of the properties of parallelograms? Angle B, right? Opposite angles are always going to be the same. That's, like I said, what's really nice is if you know one angle inside of a parallelogram, you can find all the angles inside of a parallelogram, or all the interior angles inside of a parallelogram. It's very, very helpful. So now that we have angle D, it should be pretty easy to find the measure of angle 5 and 6. If we know that 96 is this whole angle, and this diagonal splits it in half, the two equal pieces, we know that each side is going to be what? 48? So 48, 48. And by the same properties, it's going to be the same thing for angle B. 48, 48. So here, the reason why I really like these problems is it illustrates not only the properties of a rhombus, but also illustrates the property of a parallelogram. You know one angle, it should be very easy to fill in the rest of the four. And just as a little side point, what can be helpful as well, we know what these angles are too. In fact, we know that all these angles are going to be 90. All these interior angles are also 90. Very, very helpful for us. So one angle inside of a rhombus can really tell us a lot more information than in most other special quadrilaterals. So I know that's a lot to process. This is a really complex property that has a lot of implications. So you might need to watch this video again, watch me work through this example, and then maybe try to look at some of the application videos. Soon I'll be posting a video on a little bit more in-depth problems on the rhombus. Alright, thanks for watching the videos. Make sure you check out the other videos on special parallelograms. Subscribe and like.